Hello and welcome to lesson number 2 in Unit 7 Exponential Functions in our grade 11 University College math class. So as I said at the start of the first lesson, this unit in particular is more discussion driven. It's meant to satisfy the requirements of the specialist high skills major programs that we offer at our school for health and wellness and information and technology. So today's lesson usually has a lot more sort of discussion that we have going on. We're going to kind of just cruise over that, but I don't want to do I do want to do a little bit of the lesson as we go. So let's start by talking about dehydration in the context of exponential decay. And we're going to start with the definition of biological half-life. So I'm just reading from this first paragraph here. And it says, the time required for half the quantity of a drug or other substance deposited in a living organism to be metabolized or eliminated by normal biological processes. The biological half-life of water in a human is 7 to 14 days. So this means it takes 1 to 2 weeks to lose half of the water in your body. Why such a broad range? Because the half-life of water can be dramatically altered by a person's environment and behavior. What are some of the factors that would affect the rate of dehydration? So we usually talk about this. People usually mention like food, what you're eating, if you're eating salty things, how much have you had to drink, like exposure, like what are you wearing, are you outside, what's the weather like, is it cold, is it hot, were you exercising, were you not? We usually talk about lots of different things like this. So our exercise today is to explore what would happen if you were to be lost in the wilderness and how quickly you would perish from dehydration, which is a little dark now that I'm saying it kind of all by myself here as I record this. Nonetheless, we're going to press forward. So I'm going to use this space here where I would normally be jotting down the factors that affect the rate of dehydration, and I'm going to use it to make a few calculations. So let's just jump right into this paragraph here. It says, the human body is composed of approximately 60% water. So use your weight to estimate how many pounds of water you consist of right now. So I'm going to try to do this with a bit of color coding. So my weight is 185 pounds. So you'll want to put your weight here, whatever it is. If you don't know what it is, you can guess or you can use mine. It doesn't really matter. And if I want to find 60% of it, I'm going to multiply it by 0.6. which is 6 over 100, or 0.6. So as I type that into my calculator, you'll need a calculator for this lesson. So that's 180 times 0.6. That equals 111 pounds. So that's what I'm going to put down here. So that means that in my body, at this moment, I have 111 of my 185 pounds is water. It's just water. So the next part is interesting. If you were to lose more than 15% of your body weight as water, which means if you were to lose 15% of your total body weight but take it only out of the 111 pounds, it would most likely be the end of you. So how many pounds of water does this represent? I'm going to change up my colors here. So 15% of my body weight, so there's my 185 pounds, that's my body weight. Again, you can substitute yours in here, and we're going to multiply that by 15%, which is 0.15. Let's pop that into the calculator and see what we get. So 185 times 0.15, and that is 27.75. 27.75 pounds. So how many pounds of water does this represent? So 27.75 pounds. So just to recap, what we've done so far is I know my body weight. If 60% of my body weight is water, then that represents 111 pounds. If I were to lose 15% of my body weight, which in this case we figured out to be 27.75 pounds, if I were to take that out of the 11 pounds of me that is water, I would die. I would perish. So what would be the amount of water remaining in your body at the time of your death? So I take the amount that is the amount of me that is water, so that's 111 pounds, and I take away my 27.75 pounds, which was 15% of my body weight. So 111 subtract 27.75, and that's going to give me 83.25. 83.25 pounds. So that's how much water would be left in me at the time that I would die. So again, everybody's calculations for this are going to be different. And that's okay. That's kind of the design of the lesson, is that everybody's going to find that they have a sort of a specific amount of water in them and a specific amount that would be left if they were to have 15% of their body weight lost from the water portion. So now we're going to run two simulations. So I'm just going to scooch this up a little bit, And I'm going to pause and let you just sort of copy down what's going on in this table, or if you don't have the notes, just copy the table itself, just very basics, or do a very basic version of it, and then I'm going to read the part above it. So hit pause and then come on back. Okay, so you're back. It says, imagine you were lost in the wilderness without food or water. Let's assume that the maximum daily temperature is 21 degrees, and we will run 2 simulations. In the first simulation, you have found or created shelter and have thus protected yourself from the elements, so the biological half-life of the water in your body will be 14 days. In the second simulation, you have not found shelter and are thus exposed to the elements, reducing the biological half-life of your water to 7 days. How many days could you survive in each simulation? So let's look at simulation 1, then that's the 14-day. And again, I know you couldn't necessarily see it, but I just ran this. This goes down to 7 days. So simulation 1 is a 14-day half-life. So just to explain that a little bit further, if we find shelter, if we're not sort of out exposed just in nature with the wind sort of wicking water out of our body, we are going to be losing it at the slowest possible rate. So the half-life would be 14 days, the largest sort of end of the scale. So if I were to create a formula for calculating how much water is left in my body after a certain number of days have gone by. Here's number of days. I've used D there. So I would write down, and again, I'm just going to rehash this up top here. You don't have to write this down. So the water would be equal to A times B to the exponent. In this case, we've used the exponent D. Now, A is the initial value. So for me, that was 111 pounds. That's the amount of me that is water. You would put your value in here. And then B is how it's our growth rate, if we were looking at it yesterday. Today is our decay rate. And what you'll notice is this value here is 1/2. And it's because this is a biological half-life. So every day it goes down by a half, or whatever, sorry, I guess every 14 days rather, it goes down by half. So that's why we put a half here. This D is 0 days. It will be day 1 on the next day, day 2 on the next day, day 3 on the next day. And I want to point out that we've included here, as we talked about at the end of the last lesson, a denominator to our exponent. And that denominator deals with the how long does it take. And in this case, it takes 14 days for us to, the 14 days for the half-life of water in our bodies. So when I do this calculation, and I take this calculation into my calculator, remembering that it is super important to put brackets around this exponent as you calculate it. So I would type this into my calculator, 111 times bracket 1 divided by 2, close bracket, to the exponent, open a bracket, 0 divided by 14, close bracket, equals. And that should give you 111, what you started with. That's why I like to do the day 0 one first, because it's just a little bit, it's like a nice test. So if you're getting the right number, i.e. if you're getting your A value on day 0, that's awesome. Let's continue. So every day, I'm going to continue to write out this formula. So the amount of water left in my body is 111 pounds of water, half-life, and now we're on day 1 of 14, remembering to bracket that. So I'm going to type that into my calculator. I'm going to have 111 times 0.5 to the exponent, open a bracket, 1 divided by 14, close the bracket, equals. And so I get 105, and I guess I'll go to 2 decimal places here, 0.64. Now again, that's mine. Yours is going to be different. But if you're following along, what you'll notice is this should be smaller. We should be losing water. That makes sense. So let's do a second calculation. Day 2, 111, that's a half. And now we've got 2 over 14. So let's type that into our calculator again. 111 times 0.5 to the exponent, open a bracket, 2 divided by 14. Close the bracket, equals. Getting down there, 100.54. And as I said, mine will be different. I'm just working through these calculations with you. You can be doing it while I'm talking. You can just pause and kind of fast forward. It's totally up to you. So here we are on day 3, 111, 1/2 to the exponent 3 over 14. Let's put that into the calculator. Times 0.5 to the exponent, open a bracket, 3 divided by 14, close the bracket, equals 95.68. Let's keep going. W equals 111, 1/2, 4/14 this time. Let's see what we get. 11 times 0.5 to the exponent, open a bracket, 4 divided by 14, close the bracket, equals 91.06. Day 5, I'm going to stop writing this out just so we can kind of move along a little more quickly here. I'm just going to be doing 5/14 for this one, so this is 111 times 0.5 to the exponent, open a bracket, 5 divided by 14, close the bracket, equals, that gives me 86.66. And now day 6, that's going to be 111 times 0.5 to the exponent, open a bracket, 6 divided by 14, close the bracket, equals 82.47. Okay, so we've reached this point. I want you to remember that up on the first page when we were, or I guess the top of this page, 83.25 was how much water would be left in my body after I've lost the 15%. So what you'll notice is that on day 6, I'm down to 82.47. So the time that I expire is somewhere here in between day 4, or in between day 5 and 6. So I'm just going to put a little box around it. So this will be at some point in here, closer to day 6 than day 5. That would be when I expire. So I'm going to pause this video or stop this video, I guess, and then we're going to come back and we're going to run the second simulation and draw some conclusions, look at the formula for exponential decay and half-life, and then you'll be good to head to the homework. So we'll see you in part 2.